Hello, let's look at problems. Acid base, strong acid versus weak acids. Strong acids dissociates 100% and HCl dissociate H plus and Cl minus 100%. 1 molar H plus, 1 molar Cl minus, right? That means there's no HCl left over, all in the form of ions. That's what this one depicts. The picture should help you. 1 mole of HCl will give you 1 mole of proton, 1 mole of HCl. No HCl molecules left over. Look at the weak acids. 1% dissociation. So 99% in the HA form, 1% in the H plus and A minus form, right? So tiny bit of ions. That's the important thing. Almost all in the molecule side of HA, 99%. Okay. So the next question was about, yes, mono, di, and tri or polyprotic. The protic means proton, and mono is HBr, di sulfuric, tri is phosphoric examples. But look at this way, HA, H2A, H3A. That's the best way to look at it. Don't be bothered by the polyanions, okay? Right, next question. The formula used. Yeah, I prepared some examples. pH plus pOH is 14. pK plus pKb is pKw, which is 14 again. And Ka times Kb is Kw. That's 1 times 10 to the minus 14, this one, right? So always the K values are pretty small, 10 to the power minus 5, 10, something like that, okay? Now, so I also prepared, based on your questions, little scheme that you can see pH and H plus or hydronium, how do we interconvert? And pOH and OH, how do we interconvert between all of these 4 pieces, okay? So pH to H plus, take 10 to the minus pH. And pOH to OH minus, take 10 to the minus pOH. Follow the green arrow, right? You go from OH minus to pOH, take the minus log. So H plus to pH, take the minus log H plus, right? Practice that. I have a table below. Now H3O to OH, 1 times 10 to the minus 14 divided by H plus concentration will give you OH minus. Reverse, 1 times 10 to the minus 14 divided by OH minus will give you H plus. And here the pH, 14 minus pH will give you pOH, and 14 minus pOH will give you pH. So that's the table sort of scheme you need to have nearby you. So keep it on your desk and practice like this. Let's look at this table. So H plus here, OH minus here, pH here, pOH here. You can also add a column acid and base, right? Now take water, 1 times 10 to the minus 7, H plus and OH minus. That's why water neutral, no taste. And look it up, the minus log values, pH and pOH is 7 and 7. Okay, right. And somebody will put a calculator on my computer so I can show you actually how to do it in the next video. Right, I could not run it today, that calculator, on the screen. So I'll show you the little bit of more tactics on problem solving. Okay. Now, so let's get the calculator here. Yes. So if I take the hydrogen protons minus log value, I get 7.40 blood pH, and 14 minus 7.4 give you 6.6, right? Now look at the calcium hydroxide, 2 OHs, that's why 0.01 becomes 0.02 OH minus. Now take the pOH by taking the minus log. So the first pOH, 14 minus pOH give you 11 minus 30 pH. Now 10 to the power of the 1130 will give you 10 to the power of 1130 will give you H plus, right? So that's how you want to do it. So you want to practice like 2 of these tables, and then you should be fine with using the calculator. Now look at this one, 12 pH is given, go to the pOH, 14 minus 12 to 2, and 10 to the minus 2, 10 to the minus 12 consecutively H plus and OH minus, right? Okay, try to fill all of them, right? The strong acids here are nitric and sulfuric and HCl, and they fully dissociate. Okay, all right. Yeah, so I changed the question numbers. There's quite a bit of questions, so I have to drop some. Let's see. Find the molarity of formic acid solution, which has shown pH of 2.37 and the Ka is given, right? So this is how we want to do it. So actually most of these questions, you wanted to do it this way, the way I'm going to show now. Try that and see whether it works for you, right? Now, okay, the question is molarity. The pH is given, that means H plus given, right? And the Ka is given. So the formic is just to HA to me, but anyway, I put the formic HQ water, HQ minus, and H3O plus. This one I would see actually HA plus water, A minus, and H3O plus. That's the red ones are the best. Write a rice table, and molarity is looking for question mark. Water liquid doesn't care, 0 0 minus x x x m minus x. Assume this x is 0. 5% rule I don't discuss now. If you need, send me a question. Now, because you have H plus, you're going to write a Ka, product over reactants, HA plus A minus divided by HA, x squared over m. Now we're looking for m. X squared we have to get from that one is H plus coming from 10 to the minus pH. The pH is 2.37, 10 to the minus to the squared for x squared and divided by m. So let's plug it in. So the Ka value 1.8 10 to the minus 4, and squared value, brackets are important when you plug into the calculator, and we should get here yes, 1 times 10 to the minus 9. Very low molarity, so that's okay. Now let's look at the next question. Calculate the pH of potassium. pH is the question. Potassium is Ka to me because it's a polyanion. Just keep it simple, right? And then the molarity is given, Ka is given. So you're given 3 things, looking for 1, right? Kind of the reverse of the previous question. But look at the format, same format. So, but there's something, 2 steps you have to do. Salt dissociation, 100%. K plus is spectator, ClO minus, 100% molarity transfers into the ions. Now, second one, salt dissociation first, then put it in the water like this. And the water dissociates, that's the hydration or water dissociation step, and double arrow because of the water, and you write it this way. Now, the magic here, the OH minus, okay? Now, 0.1 the molarity minus XXX, and then the ice table as normally, right? And the, yes, rice goes here, and 0. Yes, so you are writing the Kb because of the OH. Kb product over reactants, plug in the x squared, right? These values, oh yes, assumption is 0 here, and x squared 0.1, right? The Kb. Now the Kb is not given, so we're going to calculate from Kw over Ka because you have the Ka given in the question, and plug in here, and x squared over 1, cross multiplication, take the root for just to isolate the x, right? So okay, yes, thanks. There is a mistake of 1 0 missing. I just plugged in that one. Okay, so x is 5.910 to the minus 5, which is OH minus in the equation. So take the minus log of the OH, that gives you pOH. So the pOH is 4.23, 14 minus pOH will give you pH, voila. It's basic, 9.76. Around 10 is actually weak base. Now look at this one, KClO coming from K from KOH, ClO from HClO. Weak acid, strong base. Strong base is 14, weak acids are around 5, and it's in the middle point is 9. That's why it's basic, something to memorize. Thank you.